So here we have the medium level command of evidence quantitative questions from the Khan Academy. And I'm just going to do these in one video. I will put timestamps below and label the problems with some descriptive words so that you can skip ahead to the ones that you are looking for. But we'll just go ahead and get started here, and really want to emphasize the process. And you'll see this again and again because I want to try to stick to the same process, and that is to always, of course, begin by looking at the question, data to support the claim. That's a very standard prompt. And then second, we will go and read the passage and identify the claim. And this is all before looking at either the graph or the answer choices. Okay, so all other things being equal, the larger a wind turbine's rotor diameter, the greater amount of energy the turbine can generate. Okay, so greater diameter, more energy. Okay, so in a research paper on wind power, a student claims that in the United States, the amount of energy generated per newly installed turbine increased substantially between 2011 and 2021. And I'll do that line again so that it doesn't actually hide the text. Okay, so there. Okay, so we've read it, we've identified the claim, and now we're going to take that with us to the graph. So energy generated. Okay, and this is a little bit tricky because energy generated per newly installed turbine, it's not directly depicted in the graph, right? We just see year and percent of newly installed turbines. So where do we find something about energy? That is where this relationship is important. So the larger the diameter, the greater amount of energy it can generate. And so if the amount of energy generated per newly installed turbine increased substantially, that would suggest that we would have more of the bigger turbines. So I'll do some color coding here. Greater than 130, those are, there. And then we've got the other somewhat big ones here. So we can see that both of those have increased. In contrast, the others have decreased. Well, that's an increase and then a decrease, and so those are the second smallest and then the smallest ones. So over time, the diameters have gotten bigger, basically. So, okay, what I want to emphasize about the answer choice part is, yes, we do need to pay attention to what's accurate, but that is more time consuming. Determining whether something is accurate is more time consuming than determining whether it is relevant to begin with. So we really want to focus on, is this answer choice reflecting something about, an increase in bigger turbines or bigger, greater diameters over time. So in 2011, nearly 80% of turbines had rotor diameters of less than 100 meters, whereas, so this is not relevant because it's only comparing the two smallest types. We want to contrast between these and these. Okay. We want to show that these have gone up and those have gone down. So A is not relevant in the sense that it is making a comparison like within that category of the two smaller sizes. No turbines in 2011 had rotor diameters greater than 115, whereas the majority in 2021 had rotor diameters greater than 130. Now, that would be relevant. So here's where it becomes important to check for accuracy once you've determined that it is relevant. And this is kind of extreme. No turbines in 2011. And that actually is accurate. B, that is accurate for the first part, whereas the second part, the majority in 2021 had diameters greater than 130. That is not correct. See, the ones greater than 130 are right here. And that is not quite correct. And so that is where the checking for accuracy comes in after you've determined that it's relevant. So B starts out good, would have been relevant, just isn't accurate. C, most turbines installed in 2011 had rotor diameters of less than 100 meters, whereas most turbines in 2021 had rotor diameters of at least 115. So yes, that is relevant because we're getting into the bigger sizes. And it is also accurate because 20% plus 65% is 85%, and that is definitely most. 2011, most of them had rotor diameters of 100 or less. Yeah, and now that I look back at B, B, the first part was accurate. Yeah, C is going to be the correct answer here, but we'll check D. The percentage of newly installed turbines with rotor diameters greater than 130 meters increased every year between 2011 and 2021. And that's not true either because it's flat. So here's a case where we have 3, B, C, and D, that were all relevant, but only one of them is accurate. Sometimes, and I think we'll see this as we go forward, a lot of times you'll have multiple choices that just aren't relevant. But anyway, that is that. So number 2, and I didn't number my steps here, but step 2 is to read the passage. Step 3 is to read the graph or interpret the graph, the table, whatever. And then step 4 is to go to the answers. So it's okay. So data to complete the statement. So after a volcanic eruption spilled lava in the North Pacific Ocean waters, a dramatic increase of diatoms, a kind of phytoplankton, near the surface occurred. There was a dramatic increase of diatoms near the surface. Okay. Scientists assumed that the diatoms were thriving on nutrients such as phosphate from the lava, but analysis showed these nutrients weren't present near the surface in forms that diatoms can consume. However, there was an abundance of usable nitrate, a nutrient usually found in much deeper water and almost never found in lava. This researcher believes that as the lava plunged nearly 300 meters below the surface, it dislodged pockets of this nutrient, releasing it to float upward. Okay, so we got to put some things together here. This nutrient would be nitrate, and then it's usually found in much deeper water, but it has floated upward here. That means there should be some evidence of nitrate near the surface in the area near the volcanic eruption, near surface volcano. Okay. Seawater in lava affected area, seawater outside of lava affected area. So we've got a division here. So average nitrate and phosphate concentrations in seawater after volcanic eruption. So lava affected area, unaffected area, outside of the affected area, and then we've got shallow, relatively shallow. I mean, 45 meters below the surface is pretty deep, honestly, but that's deeper. And then shallow and deep, or really deep, not as deep. Okay, and so nitrate levels are higher in both of these cases. Like 3.1 is a lot greater than less than 0.03, and 0.4 is greater than less than 0.01. And so something that indicates something about those comparisons, but even more important is the fact that we are looking for something that has to do with nitrate and not phosphate. Okay, so that's going to be maybe the quickest thing that we can use. And so like with A, phosphate, no. This is what I mean by zeroing in on what's relevant, because it would take a lot of time to assess whether that choice was accurate. Or I don't know if a lot of time, but it would take some time. And even if it was accurate, it might not be correct. And in this case, it's not going to be correct because their statement doesn't involve phosphate. Okay. B does. C does not, because it also talks about phosphate. And then D would be relevant. So I'm putting a check here just to indicate, that it's relevant, potentially relevant. But we need to check these and see if they're accurate and actually if they would support the statement. So for both depth ranges measured, the one that I have circled in red and the one that I have circled in yellow, the average concentrations of nitrate were higher, substantially higher in the seawater in the lava affected area. So to the left of this bar, to the left of that vertical line, they were higher there than the lava affected area. So B is going to be correct here. What is D saying? There was little change. So for first of all, D, I really just skimmed it earlier, just looking for nitrate versus phosphate. It's talking about the seawater outside of the lava affected area. That's not what we're looking. We want to see the difference between the lava affected area and the lava unaffected area. And so the answer will be B. Another data to complete the statement question. So some whale species practice lunge feeding, in which they lunge toward prey with their mouths open at wide angles. So some whale species practice lunge feeding, in which they lunge toward prey with their mouths open at wide angles, collect the prey and the surrounding water, and then filter out the water through baleen plates in their mouth. And nobody is expected to know what a baleen plate is. But anyway, we'll keep on moving. So although the volume of water engulfed or swallowed increases with the whale's body length, so the volume and the length, the surface area of whales' baleen plates does not increase with body length to the same degree. Okay, so I'm going to put surface area in red and just say that, okay, it might increase, but just not to the same degree. And that might help explain why. Okay, and let's think about this. So if they're filtering something out, if the surface area goes up, you would have more filtering because, it's just going to capture more area. And so if this isn't increasing with length to the same extent that the volume of water increases, then they're going to be less efficient at filtering, or you're not going to see as big of an increase in the filtering capacity relative to the increase in length. Okay, so something like that. And so help explain why. So we've got the longest ones here. Okay, average number of lunges per dive. Okay. Average time to filter all of the water. What is the pattern here? Okay, so here might be one where, okay, the plan B would be to kind of say, I'm not exactly sure what we're looking for, so let's actually do the plan B approach. And what would plan B involve? It would involve checking to see whether these are accurate. Again, this is going to be, relatively more time consuming, but if we don't know what else to look for, if we're feeling stuck, it's a plan B. And the other thing to note here is that these are relatively short answer choices, so they don't take that long to read. So let's just check these. So minke whales and humpback whales show similar average filter times. And that's just not correct. I mean, one is double that of the other, and so I wouldn't call that similar. Blue whales show the longest average filter time. That's correct. And the highest average number of lunges per dive. That's not correct. C, humpback whales show an average of 6.28 lunges per dive. That is true, but how could that support the statement? That's a very narrow point, and we're talking about length, differences in length, differences in filter time, so there has to be some kind of comparison. And so even though C is accurate, it just doesn't seem like something that could complete the statement. So fin whales show a longer average filter time than minke whales. So that is true. And how, again, let's say that we had another decent answer choice to go along with it, and we'd had to verify that it actually did complete the statement. The surface area doesn't increase with body length, and so if the surface area doesn't increase with body length, that does suggest that the longer whales are going to take longer to filter the water, because they're engulfing a large volume of water, but they don't have, relatively speaking, as much surface area with which to filter that out. And so that would make sense that a longer whale is going to take longer to filter things. And so D will be our correct answer there. So I've looked at these questions before. It's just been a while. I don't sit here and rehearse them beforehand. So if I get stuck during the question, you can take that as a pretty accurate representation of what it would be like, actually during the test. This isn't working. Let's try this other method. Okay, data that supports the geographers and hydrologists argument. So geo, land or earth, hydro, water. Let's read it. A team of geographers and hydrologists compared the average annual precipitation and internal freshwater resources per capita per person for 5 countries located on different continents. They found that although precipitation is an important factor in determining freshwater availability, it is not the only one. Other factors such as population size, distribution, and density, as well as water management, infrastructure, and consumption, also affect how much fresh water is accessible and usable for human needs. Thus, they argue that 2 countries with similar precipitation levels can have very different freshwater availability situations. Okay, so this one I think is maybe sometimes it's a little easier when you have the full statement to support it than when you have a blank. But in this case, 2 countries with very similar or with similar precipitation levels. So that gives us something to look at to begin with. What are 2 countries with similar precipitation levels? Not India. Australia and Canada, right? So Australia and Canada, very similar precipitation levels, but very different freshwater availability situations. And so here, we're not going to have to check for accuracy, I don't think. We need our answer choice to mention Canada and Australia. Canada and Australia. And honestly, we do want to be careful and read it so that we don't make a silly mistake, but Sierra Leone and Brazil, they don't have very similar precipitation levels. This one only mentions 1 country, and D, this mentions similar amounts of freshwater resources. But no, we want similar precipitation levels, and that's something that only really occurs with Canada and Australia here. So it's definitely going to be A. Data to complete the assertion. So, to investigate the influence of certain estrogen-responsive neurons on energy expenditure, researchers treated female and male mice with either saline solution or, I'm just going to call it CNO, which activates the neurons. And this is a little bit complicated. I'm going to do a little 2x2 thing here. And also just note something that you might already know, but might not, or might have kind of gotten hazy on it. But saline solution, or this complicated sounding compound, clozapine N4 oxide. Okay, we want to be able to identify in a situation like this what our control group is. Okay, as it says here, they were looking to investigate the influence of estrogen responsive neurons, something that activates the neurons. So that means if they're treating them with either saline or this compound, saline is going to be basically like our placebo. That's going to be the control group, essentially. So we've got males and females, and then we've got saline and CNO. But again, this is the control group. It's kind of like if you're testing out a new medication, you want to see how well it helps, treat headaches. Maybe you give 50 people probably more than 50, but you give 50 people a placebo and 50 people the medication, and then you don't tell them which is which. But the control group and the experimental group, you got to give them something so that they, it's not a giveaway that, oh, these people didn't get medication at all. In this case, the saline solution would be essentially like the placebo. It's not something that's going to have a big impact on, as it says here, energy expenditure or estrogen responsive neurons. Okay, so monitoring the activity levels of the mice by measuring how frequently the animals broke infrared beams crossing their enclosures, they found that mice in their study showed sex-specific differences in response to neuron activation. Okay, and again, this one is pretty complicated for a medium-level question. But what are they saying here? So they're monitoring the activity levels. It doesn't really matter so much how they are doing that, except that we need to be able to connect this portion here with the graph. So how frequently they broke these infrared beams. You can imagine the infrared beam as being kind of like a, just it's some kind of marker. It's kind of like when you go into the grocery store or they've got the automated double doors, and it senses that you're here and then the doors open. There's a door and there's a door. Okay, you're breaking a beam. And if something could measure how frequently people went in and out by measuring how frequently they crossed that beam. Okay, something like that here. It's a measurement of how active these mice are. And given that there are sex-specific differences in response to neuron activation, well, that's going to mean sex-specific differences in response to this CNO. And given, that estrogen is a female hormone generally, we might expect this to be a greater and therefore this to be less. The increase in activation relative to what you find in the control condition. Okay, so in other words, we would expect this increase to be greater than that increase. Maybe this will be flat and that'll be greater. Something like that. Okay, so what is going on here? Maybe I should color code this a little differently. Here are the two female scenarios. So one of them, we have a big increase. And it's hard to track the others, but something like that. Okay, so that's a fairly big increase. Whereas with the males, and this is going to make things really, really messy here, but with the males, we don't really have much of an increase at all. I'm sort of covering the two remaining lines there. So you have a bigger increase in CNO-treated females than you do in CNO-treated males. D, and I'm looking at this bottom up here, CNO-treated females showed more activity relative to saline-treated females than CNO-treated males showed relative to saline-treated males. But here, I think it's important to be able to identify what the control group is versus the experimental group, and to pick up on the fact that saline does indicate that we have a control group. Again, I'm not sure what they're expecting people to be able to figure out. What people have learned in their science classes, that's a little bit more content specific than they usually get on the SAT. But anyway, that's what's going on there. So what about the other choices? The 4 groups of mice differed greatly in their activity levels before treatment, but showed identical levels. So first of all, that's an extreme word. I mean, identical means they've got to be exactly the same, and even if they're similar, they're not identical. I mean, among other problems with answer choice A, that's one that we could point out. B, CNO-treated females showed a substantial increase and then decline, whereas CNO-treated males showed a substantial decline followed by a steep increase. So not really true that the males showed a decline followed by an increase. So the second part of that is incorrect. But it's also just not about increase versus decrease. It's about the degree of increase in the females versus the degree of increase in males. And so B is going to be incorrect. And then C, saline-treated females showed substantially more activity than saline-treated males did. Well, here, that's not relevant at all because C would just be comparing the control group situation. And we want to know what happens when they're actually exposed to this chemical. And so C, not relevant. And again, it's going to be D. Number 6, data that supports their conclusion. So step 1, read that. Step 2, read this. Step 3, assess the table. Step 4, look at the answer choices. So what is their conclusion? So digital paywalls restrict access to online content to those with a paid subscription. In an investigation on the effect of paywalls on newspaper company revenues for print and digital subscriptions and advertising, its researchers compared actual outcomes with a paywall to control estimates without a paywall. Okay, the researchers concluded that introducing a paywall is more beneficial for larger newspapers, which have a high circulation and tend to offer a substantial amount of unique online content. So the relevant comparison here has to do with, well, large versus small newspapers, right? Because if it's more beneficial for larger newspapers, that means it's less beneficial for smaller newspapers. And so we want to compare, we want our comparison to involve a large versus a small, or multiple large ones versus the 2 small ones. Okay, so in other words, either the Chicago Tribune, the LA Times, or the New York Times versus the Denver Post or the Sun Sentinel. Okay, so the Chicago Tribune and Los Angeles Times had similar revenue changes. Nope, because here we're comparing 2 large ones. 2 large ones, and that's not what we want. Same thing with answer choice B. The Los Angeles Times had a 12.5% revenue change, while the Chicago Tribune had a 19% revenue change. Again, that's a within category comparison. We want our comparison to be across categories. Again, with those categories being large and small. The New York Times had a 20% revenue change, while the Denver Post had a negative 1% revenue change. Large and small. And then D, the Denver Post had a 1% revenue change, which was the smallest, and so that's just one small one. So we only get one answer choice that has 1 large and 1 small. And so we don't really have to check to see that it's accurate because it's the only one that's relevant. Okay, so kind of contrasting with what we saw way back here where 3 of them were at least potentially relevant. And then number 7. So which choice most effectively uses data from the table to complete the text? The Ramayana, composed in Sanskrit and dated variously from 500 BC or before Common Era to 100 BC, is one of the most influential epics in world literature. It is often compared to the Iliad and the Odyssey, the classical Greek epics that depict the Trojan War and its aftermath. All 3 epics explore themes such as love, loyalty, and the struggle between good and evil, and feature a range of divine and human characters. However, okay, so this is a very open-ended statement, but if we look at the graph, it is talking about the number of lines of verse, and given that the passage is talking about the Ramayana relative to the Iliad and the Odyssey, that would be the relevant comparison. The Ramayana is much longer than these 2. And then we can verify that it's accurate, and it is. And it's always nice when you get an A, on a question like this because, it's an open-ended prompt. We potentially have to read all the choices or at least scan through all the choices. That's definitely going to be correct. And on the test, you could just bookmark it and say, I'll come back and check B, C, and D if I have time. But let's just look at them now since we're here. Of course, you can skip ahead using the timestamps, but the Aeneid is just not talked about in the passage. And that's not accurate. Anyway, it's not that close. It's not shorter than the Iliad. That's just incorrect, because it's the longest, and it's significantly shorter. No. It's not shorter. It is the longest one. So number 8 here, which choice most effectively uses data from the graph to complete the statement? So we will read the passage here. In high concentrations, hydrogen sulfide, or H2S, is typically toxic to many plants. Researchers wanted to understand what effect low doses of H2S might have on plant growth. They treated these different types of seeds with various concentrations of H2S and tracked the germination of those seeds along with the germination of untreated seeds. And so a few questions ago, I talked about identifying the control group. This would certainly be the control group here, the untreated seeds. But anyway, treatment with particular concentrations of H2S was associated with accelerated germination. Okay, and this is why I always emphasize reading the passage first before going to the graph, because, there could potentially be any, number of things. Is that good grammar? There could potentially be any number of things that might be relevant from the graph, and we don't necessarily know what to zero in on. But once we've read the passage, we know, okay, we're looking for, accelerated germination, and that means we're probably looking for something to do with this curve. But not only that, probably something related to this time, this time interval, time value, because that's where the differences are the greatest. Whereas up there, they're not that different, and there, they're not that different either. So if we're trying to complete the statement, and the statement has to do with accelerated germination as a result of treatment with H2S, we're probably looking here, the 10 micromoles per liter treatment, and then 48 hours. And so 168 hours, well, the first part of it is accurate. More than 90% of seeds had germinated, but the second part is not. Less than 70% of untreated seeds had germinated, and nope, it's close to 80%. So it's definitely not less than 70%. So that was close, but again, I don't think that wouldn't have been the best choice for them to create as a correct answer, because again, that difference isn't as pronounced up here as it is over there. At 48 hours, approximately 50% of seeds treated with H2S, and no. So even though this is talking about 48 hours, which I think we do want to zero in on, that first part is not accurate. So it doesn't matter how accurate the rest of it is, although the second part does look accurate in B, but again, the first part's not accurate, so B is incorrect. C, we don't want to pick that, because even if it is accurate, we don't have a difference. There's no difference to speak of. I mean, it's a minor difference. You can barely see it. I'm just not even going to worry about checking that. And then D, well, it's going to have to be D, but at 48 hours, more than 70% of seeds treated with 10 micromoles per liter had germinated, whereas only approximately 50% of the untreated seeds had germinated. And so that is correct. And so the answer there will be D. Data that supports the student's conclusion. So to understand how expressions of anger in reviews of products affect readers of those reviews, researchers measured study participants' responses to 3 versions of the same negative review. So what are those 3 versions? There is a control review expressing no anger, a review expressing a high degree of anger, and a review expressing a low degree of anger. Reviewing the data, a student concludes that the mere presence of anger in a review may not negatively affect readers' perceptions of the review, but a high degree of anger in a review does worsen the readers' perceptions of the review. Okay, so the perception of the review, not the thing being reviewed, the perception of the review. And so we look up here, we've got no anger, the control, high anger, and low anger. And so if we look at the measurement of helpfulness of the review, we see that the high anger condition, yes, that is the lowest. It is knocking it down by about a point in terms of the score, whereas no anger versus low anger, we could basically say that that's no difference. There's no difference there, because anything, any difference that you have there is inconsequential and probably, not statistically significant anyway. And so we want to pick something that indicates that the high anger group, or the high anger reviews, had a lower average or mean helpfulness rating. So they were substantially higher. No, it's not regardless of which type of review. I think B seems pretty accurate. Compared with participants who saw the control review, participants who saw the low anger review rated it as slightly more helpful. I mean, maybe. Whereas participants who saw the high anger review rated it as less helpful. Yeah, I wouldn't have, slightly more helpful. I mean, even that is kind of borderline to say that it is even more helpful, but it's accurate. It's accurate. C, participants who saw the low anger review rated the review as slightly more helpful than did participants who saw the control review, or than participants who saw the control review did. But participants' attitude, well, this attitude toward the review subject is something that we can ignore here because it's not part of the student's conclusion. And so C is talking about things that are just not, the student doesn't conclude anything about the attitude toward the review subject, meaning the thing being reviewed. Then D, so B versus D. Compared with participants who saw the low anger review, participants who saw the... See, D, the problem with D here, I would say, is that, again, the student's conclusion is focusing only on perceptions of the review and not the attitude toward the review subject. And so D veers a little bit off, not off topic, but I mean, it gets into things that aren't part of the conclusion. And so that's why I would go with B here. The data to complete the statement. Guilds, local associations of artisans and merchants in the same industry, were widespread in France from the medieval period until the late 18th century, but guilds were much more numerous relative to the population in some cities than in others. Okay, so I would look for, well, the two that I would not look at would be Bordeaux and Lyon, because those are pretty similar in terms of inhabitants per guild. And so that's going to be, how numerous they were relative to the population. That's going to be reflected in the number of inhabitants per guild. So I would look for, Paris versus Rouen, if I'm pronouncing that not too incorrectly, or possibly Paris versus either Bordeaux or Lyon. Okay, so no. Oh, well, B, Bordeaux and Lyon. So it's accurate. No, it's not accurate, because the two cities don't have nearly the same number of nearly equal numbers of inhabitants. They have pretty different numbers of inhabitants. It's hard to get all this on the screen in a way that is properly zoomed in. Okay, it's got to involve a comparison. So B is not going to be correct. C is going to be correct, because it's making a comparison between two cities in which the number of inhabitants per guild is pretty different. D, inaccurate. It had fewer inhabitants and fewer guilds. Maybe proportionately more guilds per person, but that's not what the answer choice is saying. So that'll be C. And then the last one in this batch, data to complete the statement, something to do with suggestions for improving a university. So researchers reviewed suggestions for improving a university that had been submitted to the university's president. They coded each suggestion as additive, meaning the idea suggested adding something new to the university. Subtractive, the idea suggested removing something from the university. Neither, or invalid. The data illustrated people's tendency to overlook the possibility of removing things to achieve improvements. Okay, so if people overlook the possibility of removing things to achieve improvements, then that means we would expect the number of subtractive suggestions would be low, relatively speaking. And that is what we see here. So the subtractive solutions, there were fewer than 100, less than 100, fewer than 100 of those. We don't really care about the invalid ones. It's really more about subtractive versus additive or neither. So fewer than 100 suggestions were coded as subtractive, correct, whereas more than 500 or 550 were considered or coded as additive. Again, on the test, I would just go ahead and put that one in and maybe bookmark it and come back to check B, C, and D. But since we're doing these here, let's just go ahead and look at them. So more than 100, 350, yeah, so invalid, that's just not... even though the second part of B is correct, there's no place in our answer for a reference to the number of invalid suggestions because that has nothing to do with what they're saying there. C is potentially relevant, but it's just inaccurate. It's saying 175, but 175 corresponds to that bar, neither additive nor subtractive. And then D doesn't mention anything about subtractive suggestions, and so that will be A.